Hello everyone, this is PM Chalapandi here. I welcome you my today's session. So in this video, we are going to discuss about how to solve this problem by using Fourier Transform. First, let me read the problem, then I will explain how to solve it a step-by-step process. So here we are given a function f of x which is defined by a square minus x square, right? When mod x less than a. If mod x greater than a, then your function is 0, right? So here, our task is to find its Fourier transform in the first case, okay? We have another case. In the second case, the help of that Fourier transform results, we need to deduce this definite integral, which is equal to pi by 4, okay? So here we have two steps. In step 1, what we are going to do? We are going to find out what is the Fourier transform, okay? In step 2, what we are going to do? We are going to figure out how to deduce this results by help of Fourier transform, right? So let me break this concept to understand how it works, step by step process. Okay. As usual, the first step is always we have to write the general Fourier transform formula. So I have written the general Fourier transform formula. Once you write the formula, then your next step is you have to adjust this formula depends on this information, right? So here I'm going to adjust my limit from this minus infinity to plus infinity to this limit, because here our function f of x is defined only minus a to a, right? So that is why from this limit to I just adjust minus a to a. Okay, right. Let's come to the second term. It is f of x. Here you have to write what is your f of x. That you can pick in your question, right? So in your question itself, it can be clearly said what is f of x. It is a square minus x square. So after writing this, let's move to expand this exponential part. So you can take the Euler's formula to expand this. By help of Euler's formula, it can be expanded as cos sx plus I sin sx. So what is the exponential expansion by help of Euler's formula? It is e power I theta, right? So it can be expanded by help of Euler's formula, cos theta plus I sin theta, right? So instead of theta here, what we have? Yes, we have Sx. Okay, so the same expansion here I have expanded in terms of Sx, right? Let's come to after expanding this. What you have to do? Yes, you have to multiply this f of x with this exponential expansion. So when you multiply this expansion, this f of x with this expansion, what you will get? You will get divided into two parts. Okay, let's come here. Here you can see the two part. Okay, so this is your first part. This is your second part. Here you have to understand the function clearly. So what you have to understand? You have to understand whether the given function is even function or odd function. Why we are checking even function or odd function? Because our limit is symmetry, right? So if you have any symmetric interval, okay, depends on your function is even or odd, you can give some direct result to you to integrate this expression, right? Let's check how it works. So so obviously it is symmetric limits. So I already have set what do you mean the symmetric limits, okay, in my previous video. So here first, to check this function is f or to function is even or odd, first write what is the condition. So you need to check this condition. It is f of minus x, right? So let's come here. If you get your answer in terms of positive f of x when you check this condition, then your function is even. Suppose if you get minus of f of x when you check this condition, then it is odd. Okay, let us come to the first function. It is f of x is equal to a square minus x square. So let us check whether this function is even or odd. So here to check the condition, the function is even or odd. This is our condition. So what is saying in the condition? We have to put minus before the x wherever we have in our f of x. So here we have x. So before x we have to add a minus. After simplification, what we should get? If we get f of x, so here a square minus x square, this is again f of x. So if we get f of x, then your function is even. Okay, suppose if we get minus f of x, it is odd function. So the first function is even Let's come to the second function, cos Sx. So in cos Sx, what you have to do? You need to add a minus before this x. So cos of minus theta is what? It is cos theta. Okay, it is cos x. Right? So what is cos x? It is f of x. So again, it is even function. So when you multiply even function into even function, it is again even function. Let's come to the second term. Here also we are having the same symmetric limits. Let us check the function. So already we checked. This is the even function. Let's move to check this one. So it is sine of minus x. So sine of minus theta is nothing but it is minus sine theta. Right? So what is the value? Minus sine theta means it is minus f of x. So if you get minus f of x, then your answer is odd function. So here you have even function in first function. In the second case, you get odd function. So when you multiply even into odd, it is again odd function, right? So in the symmetric limits, if you get odd function, then the integration, the evaluation of this expression is 0, right? Okay, so you can evaluate only this expression. And there is one more result that you can use this even function in the symmetric limit. The result is when you have even function in the symmetric limits, you can adjust your limit from this expression to 0 to a. Because whenever we have our limit in terms of 0, that will be easy when we substitute the limits after integration. Because that will make some terms directly to 0, right? So that is why we are converting this expressions to this expression. But when you convert from this to this, you have to add, you have to multiply 2 before this expression, right? So see, here I have multiplied 2. Okay. Now from this expression, you want to integrate this expression by help of some formula. Okay, that answer will be multiplied with this expression, right? So to integrate this, I'm having f of x, then another f of x, it is udv form, udv. So always you have to choose your the easiest to form. Okay, what term is easy to differentiate, that has to be treated as u, because only that value will give 0 at some point of differentiation. Okay, so the condition to choose u is when you differentiate your u, you should get 0 at some point of differentiation. In that aspect, you have to choose your u, right? So if I choose this one, definitely I will get 0 at some point of differentiation. Let's see how it works. Okay, first you choose your u. The first differentiation of u is minus 2x. The another differentiation of u is minus 2. If you go to next differentiation, you will get 0. So here, this is your successive derivative. Let's come to the formula, Bernoulli's formula. So here it is udv. We are going to use Bernoulli's formula to integrate this expression. So in Bernoulli's formula, after doing all these process, let's come to find the successive derivatives pair. So here u double dash is the successive derivative. The pair of u double dash is v2, which means we have to find till v2 in v series, right? So v series is nothing but first you have to choose u. The rest of the part has to be treated as dv. So you just divide this into two parts. One side, on this left side, you have to differentiate. At the same time, on this right side, you have to integrate, right? So when you integrate dv, your answer is p. So we need to get till v2 because our successive derivative on this side is u double dash. So the pair of your u double dash is v2. That is why we have to figure out till v2 on this process. So when you differentiate v with respect to x one more time, you will get what is v1. Similarly, what is v2? Now you got all the results which you need to substitute in this formula, right? So after finding all these results, let's come to substitute these results in this Bernoulli's formula. So what is saying in the Bernoulli's formula? In the first step, we have to write the multiplication of uv. This is u and this is v. Okay. So you have to multiply these two in first term. So that multiplication part I have written here. Let's move to the second term. In second term, you have to put a minus. So I just put minus. Then multiplication of u dash and v1. These two. Okay, you have to write in the second term. So okay, as you see, this is the second term. Let's move to this third term in the same way. Okay, after substituting all these results, now you can substitute your limits. So when you substitute your limits, you will get this one, right? So after simplification, you get this one. So far, you are just evaluating what is the integration part of this expression. So after evaluating, after finding the results to this integration part, what you need to do? You need to multiply the result of this expression with this result, right? So as we discussed now, we are going to multiply the result with that expression. What is that expression? It is 2 by square root of 2 pi. Okay, with this the multiplication of this expression with this one is your f of s, that is your Fourier transform. Okay, so successfully you completed of finding Fourier transform in step 1. Let us move to find the deduction part, that means the definite integrate part by help of Fourier transform. So for that, what you need to do first? First, you need to write what is the inverse Fourier transform formula. Okay, friends, I already told you, you have to choose only two formula to solve these type of problems. The first formula is Fourier transform. The formula is Fourier inverse transform, right? So these two formula help you to solve these type of problems. Okay, as we discussed now, I just have taken inverse Fourier transform formula. So this is your inverse Fourier transform formula. So in this formula, what you need to do? You need to substitute your f of s first, right? So what is your f of s? This is your f of s, right? So here, this is your constant term. I'm going to keep this constant term in the outside. So already we have 1 by square root of 2 pi. When you multiply this result with this one, you get 2 by square root of 2 pi, square root of 2 pi, right? Now let's come to the right f of s. The rest of the part I have written here. This time you can expand your exponential part. This time you have minus in power. So you can expand, depends on the minus in power. Okay, by help of Euler's formula, you can expand like this. Understand? So after doing all this process, what you need to do, you have to multiply this expression with this one, okay, and this expression with this one, as you have done in the step 1. So definitely, obviously, you're going to have you're going to have this expression with the two part, right? So in first part, you will be having this expression. In the second part, so obviously it is going to be 0 because it is sin sx. So when your function in symmetric limit, if your function in symmetric limit in terms of sign, definitely it will be odd function. So the odd function in the symmetric limit is always 0. So you don't need to evaluate. Okay, you can directly put that part is 0. So I just get rid of the second part. I have directly written what is the first part. Okay, you can write here minus 0 because the second part is 0, right? After writing all this process, here I have written a square minus x square, because what you have on the left side, f of x, right? So f of x is what? It is a square minus x square. That also you have to write parallelly. Now let's come to here. Here, what is my deduction part? So almost I have got my deduction part, right? So on this side, I don't want this part. Then I don't want here. I forgot to write one more thing. Sorry. Here, when you multiply this expression with this one, you will get cos sx into ds minus 0, right? So here I don't want this expressions also, right? So now let's somehow mathematically I have to get rid of all these unwanted part as we have done in the previous problem, right? So here to get rid of a, I'm going to put 1. A is equal to 1. Now to get s by t, I'm going to replace s by t. Instead of to make disappear this part, I have to put x equal to 0. Because when you put x equal to 0, it is cos 0, the value is 1. Right? When you replace s by t, you will get in terms of t. When you put a is equal to 1, you will get your expected results, right? Now let's see how it works. So what we have on the left side, a square minus x square. What is the value of a? It is 1. 1 square is what? 1. 1 minus 0, 1. That's all. Let's come to the right side. So here, one second. So here, this 2. So one more thing that I forgot to say. So here I just adjusted my limit from this one to 0 to infinity because this is even function. When you adjust this expression to from this to this, you have to multiply 2 before this expression, right? So what will come? So here 2 is common. You take outside 2, it will become 4. Now you can take cross multiplication. You will get this one. Okay. So this is your expected results, right? So as we discussed in the previous problem, dear friends, please you study well the formula of Fourier transform and inverse Fourier transform. So I'm sure these two formula definitely can help you in solving this problem.